So hi everybody, my name is Frederic Wauthelet. I am an HPC system engineer and in charge of the management of the HPC infrastructure at the University of Namur. And I'm very pleased to present you the first session of the 2021 CÉCI HPC training called Introduction to High Performance Computing. It is a schedule of the CÉCI training. These 2021 sessions goes for the basic usage of the HPC cluster to parallel MPI programming, debugging, and profiling applications. Here is the complete schedule. Is the complete schedule of this session. So, as I already said, these training sessions cover almost everything you need to use an HPC cluster in the most effective way. But what is HPC? HPC stands for High Performance Computing and refers to any computational activities that require more than a single computer to execute the task. For these activities, we use supercomputers and computer clusters. Here is an example of one iconic supercomputer, the Cray 1A, developed by Cray in 1907. For comparison, your smartphone in your pocket is more than 1,000 times more powerful than this supercomputer. But modern supercomputers are mostly computer clusters. So a cluster is a group of servers that work together and can be seen as a single computer. This picture shows you one of the most powerful cluster in Europe, Mare Nostrum, operated by the Barcelona Supercomputing Center, located in the 19th century chapel. A cluster is composed of compute nodes. Basically, a compute node is a powerful computer, and each compute node may have several cores. And a core can be considered as a processing unit. In high-performance computing, we use the flops as a unit to measure the computing power of a cluster. A flops is an arithmetic operation on floating point number. Today's supercomputer are the power of several petaflops, 10 to the power of 15 floating point operation per second. The top 500 project run the 500 most powerful supercomputer in the world. Currently, the #1 supercomputer is located in Kobe, Japan, and it has a power of 400 petaflops. And this supercomputer consume the power consumed by this supercomputer roughly equivalent to the power consumed by a city of 100,000 inhabitants, just for one cluster. But we need more powerful clusters. Several countries compete to set up the first exascale system. Exascale systems are capable of 1 exaflops. That means a billion floating point operation per second. The first European pre-exascale cluster is UMI. It is installed in Kajani, Finland. And this cluster are roughly the same power that 1.5 million modern laptops. And it occupies the space of tennis court. As Belgium is a member of the UMI consortium, all the Belgian researchers can access this supercomputer. In Europe, supercomputers are organized in an HPC pyramid. At the top of the pyramid, we find the most powerful supercomputer in Europe. I will show you. And next, Tier 1 supercomputers are mostly national and regional supercenters, and Tier 2 supercomputers are mostly located in university and research centers. In Europe, access to the Tier 0 supercomputer is done via PRACE. PRACE stands for Partnership for Advanced Computing in Europe. And the every supercomputer are accessible to all the researchers through around the world through call of proposal. And it is one of the most powerful tier 0 supercomputer is Jewel, located in Jülich, Germany, close to Cologne. And the supercomputer is accessible through Trace. And this supercomputer is used mainly for numerical modeling for the Earth system to understand the climate change. As I already said, tier 1 supercomputer are mostly regional and national supercomputer. You cannot use tier 0 supercomputer without testing your application on a tier 1 supercomputer. It's the same for the tier 1. You have to test your application first on tier 2 supercomputer before using tier 1 supercomputers. In Belgium, tier 1 and tier 2 are funded at the regional level. The Flemish Computer is an organization making supercomputer available for both academic and industrial. In the French-speaking part of Belgium, le consortium des équipements de calcul intensif is supported by the Fund for Scientific Research and the Walloon region. The current tier 1 in the Flemish regions is called Brainiac, and it's operated by the KU Leuven. And the tier 2 supercomputer are located in the 5 Flemish universities. In the French-speaking part of Belgium, the most powerful supercomputer is located at Gosselies, close to the Charleroi Airport, as it is operated by CNERO. CNERO is a research center for the aerospace sector, and a share of 60% of the supercomputer is devoted for the university users. And as in the Flemish region, the tier 2 supercomputer are located in the 5 universities. So UCL20, Galbi, Liège, Mons, and UNamur. What is the CÉCI? CÉCI stands for Consortium d'équipements calcul intensif. It's a consortium of high-performance computing center of the 5 universities in the French-speaking part of Belgium. And this consortium is funded by the FNRS and the Walloon region. And the 4 tier 2 supercomputer are accessible by all the researchers for the member universities. There are currently 4 clusters at CÉCI. And the cluster at CÉCI has been designed to accommodate the large diversity of needs of the researcher of the 5 universities. So, for example, several clusters are designed for a sequential workload. It's the case for Hercules 2 and Dragon 2 located in UNamur and in Mons. And the other one are mostly designed for a parallel workload. Also, the Dragon 2 cluster as well as the Hercules 2 cluster provide GPU. The CÉCI infrastructure is currently being upgraded. So Lemaitre 3, located at the UCL20, has been upgraded in 2018, and Hercules and Dragon has been upgraded in 2019. And NIC 5 has replaced NIC 4 last year. So, and there are currently more than 400 active users on from the 5 universities at the CÉCI running on the 4 HPC cluster. And you can see here the field or application that is summarized in this type cloud. You see that. And we have user and the informatics. The CÉCI also provides a central storage solution, which is visible for all the front-end and content nodes of all the CÉCI cluster. So each cluster has its own gateway that acts like a cache to access the data. And the main purpose of the storage is to use the user data to be shared between the different clusters, as well as the software built for each cluster. As this distributed storage provides a common directory for all the CÉCI cluster, there is no need to transfer your data using, for example, LCP between cluster using the public network. And the use of a common software repository allow all the software installed on the cluster to be available on all the clusters. In a nutshell, a computer cluster is composed of 4 parts. One or several login nodes allow the user to connect to the cluster. Computing power is provided by several dedicated computers called compute nodes. And shared storage allow the user to store the input and output file as well as the software. And a high-performance network interconnect all 3. From a login node, you can manage your file, prepare your input file, and submit jobs. Computational heavy jobs must be submitted to the compute node. You cannot run your job directly on the front-end node of the cluster. On the CÉCI cluster, there are several levels of storage. Depending on the usage, you should use a specific storage. For example, for IO intensive jobs, you should use the storage attached to the compute nodes or the high performance global scratch. On the other hand, the CÉCI home should be used only to share data between the CÉCI clusters. And our CÉCI cluster are running Linux, mostly Red Hat derivative like CentOS or Scientific Linux. Let's go through the HPC resource available at CÉCI. As stated before, each CÉCI cluster has its own different characteristics. For example, if UNamur, RPLS2 is a high memory cluster designed to run memory demanded jobs. Also, storage configuration has been adapted to cope with jobs that needs that generate or consume a large amount of data. For example, you can use up to 8 terabytes of RAM of disk, on the compute nodes for the duration of your job. And the compute node have up to 2 terabytes of RAM. Also, currently there is only one node with GPU on Hercules, mainly for testing purposes, but more GPU node will be installed soon, in the next month. And support at UNamur is provided by Juan and myself, and we also operate other HPC resource in cluster dedicated for the students and user for training. At UMOS, Dragon 2 provide high performance nodes and also provide nodes with high performance GPU. And at UMOS, the support is provided by Sébastien. And also at UMOS, they manage other HPC cluster for specific usage, but this cluster are not available to the CÉCI. At UC Louvain, the Metro 3 is in production since 2018, and this cluster provides more than 2,000 of core and also designed for parallel workloads. And at UC Louvain, the support is provided by the CSM teams. And also the UC Louvain operate an HPC cluster called Manbach. Charles Manbach was in fact a friend of Georges Lemaitre. And this cluster is made of several generations of hardware and provide access to GPU and Xeon 5. But this cluster is not available to the CÉCI. At Liège, there is a new cluster available since last year, and with more than 4,600 AMD core, this cluster is designed for parallel job and intensive IO. And at Liège, support is provided by as already said, hosted and operated by Scenario, Xenode has a total of more than 30,000 cores with up to 64 GB of RAM, interconnect with a fast parallel network. Also, this cluster has 350 terabyte parallel file system. 60% of this cluster is reserved for the university user. You should contact your local support to get access to the supercomputer. Okay. Enough of marketing. Let's go practical, and let's see how to get an CÉCI account. Now, first, you go to the CÉCI page, and you click on Create an account. You fill your email address. Please note that you must use your university email address, email like a Gmail, Hotmail, whatever, are not allowed. Okay. And then you will receive a link, mail with a link. You follow the link, you fill the form, and you will receive your key to connect to the CÉCI, to the CÉCI cluster. The key you receive is protected by a passphrase. If you lose your password, you have to restart the procedure. You cannot recover your password. And when your account is created, you will have to connect to a login node of one of the CÉCI cluster. Connection to any CÉCI cluster is done using the SSH protocol. SSH is the secure shell. It's a remote protocol that allows to connect to a remote server of a network in a secure way. To use SSH, you need an SSH client on your machine. On Windows, there are several applications available, but at CÉCI, we recommend the use of mobile external. On Linux and macOS, you normally already have an SSH client installed by default, and you can use the standard SSH or CP command to connect in the cluster. So, mobile external is a software that is easy to use and don't need to be installed on your computer. And in the same application, you have a terminal to interact with the login node, and a file transfer utility that allows you to download or upload your file on the CÉCI cluster. When you are connected to a login node, the software that interprets and executes your command is bash. So bash is called a shell. It's a command processor that can be used for an interactive or non-interactive manner, like Python, R, etc. You can write a bash script. On the CÉCI cluster, bash is the default shell. And I'll show you later, but shell scripts are written in bash. To use an application on a CÉCI cluster, you need to load the corresponding module and by using the command module load. To unload a module, you should use module unload. To list all the module available module list, all the module loaded module list, all the module available module available, and then module spider allow you to search for specific module based on the need. And here you can see an example. You can see that if you type module available on a login node of a CÉCI cluster, you find that is several applications installed, and you can also see that several applications are available. There are several versions available for the same software. So you can switch between versions of the same software. Now, these topics are addressed in the following session. So, introduction to Linux and command line, connecting with SSH from Windows, connecting with SSH from Linux and Mac, and introduction to modules and software on a CÉCI cluster. Batch jobs. And I know how to run my simulation on an HPC cluster. you can use an HPC cluster in an interactive manner by running batch jobs. You should use the interactive processing for short tasks with a user interaction or graphical application. You should use the batch processing for long-running or parallel processes, or when you run a large number of short jobs. You can run up to several thousand jobs at the same time. Batch job are submitted to the job scheduler. The job scheduler, in fact, is the software that manages the jobs on the HPC cluster. It manages the job queue and run the jobs. Once submitted, you can log off and wait the job to complete. You submit batch job to the scheduler with the details of which resources you need: memory, number of CPU, software license, etc., processor type, etc. And you add the command you want to run. And on CÉCI cluster, the job scheduler is called Slurm. To submit a batch job, first you need to connect to a login node. And when you submit the job to the job scheduler, as I already said, you have to specify the resource to be reserved for your job. On every time, on the time allocated for your job, the memory, etc., non CPU, sometimes the software license for commercial application, and as well as the list of instructions or software you want to be executed in the job. And on CÉCI cluster, the job scripts are written in Bash. Let's create a simple script for this job. Here you can see the requirements. So on one CPU, one error with almost 1 GB of RAM. You submit your job using the sbatch command. So this command submit your job to the job scheduler. You can see if your job is running. Yeah, it's running on this node. And when the job is finished, the command return nothing. When you submit the job, the sbatch command return that's called the job ID. The job ID is all the system, all the Slurm refer to the job during its lifetime. So if you want to get information or you want to cancel a job, you have to use the job ID. By default, when a job is running, it automatically creates a new file called slurm-jobid.point.out. But you can override this behavior using sbatch actions. For example, for the jobs, you can see that we can hello world in the output. Beware that Slurm will automatically kill your job if your job consumes more memory that you have requested and when the time is over. So if you request 1 hour of time for your job, after 1 hour, your job is automatically killed by Slurm. It's the same for the memory. If you overlap even the one with 1 byte the memory, it automatically kills your job. So you can cancel a job for waiting of a running job by using the scancel command. And hopefully you can only delete your own jobs. The SQ command should show you all the jobs running on an HPC cluster. By default, you can see here the job ID, the job owner, the state that is here. All the jobs are running, the number of nodes allocated for the job, and the time consumed by the job. You can see also here on which node your job is running. To help you to write a job script, on the CÉCI website, we provide a job script generator. You can choose your cluster and your requirements, and you automatically generate a job script you can use as a template for your job script on the CÉCI cluster. Slum also provides several advanced features. For example, array jobs lets you submit the same jobs dozens of times with different input. So it's a lot quicker than manually submit job multiple times. And each instance of an array job will have the same requirements. So array jobs are usually used for parametric jobs. So you have a job and you submit it, and you have a job script. When you submit the job script, it automatically generates many jobs called job array. For example, the dispatch option to create a job array, the option for creating job array is -- array. And for example, if you want to submit a job array with the index between 0 and 31, you have to use this line. If you want a job array with index of 1, 3, 5, 7, this one. Here you can submit a job from 1 to 7 with a step of 2, for example. And you can use the percent to limit the job of a job array running at the same time. So if you submit a job with thousands of elements, if you want to limit the execution to, for example, 10 jobs at a time, you can use percent and 10 for it. Here is an example of a job array. Now, I've submitted a job script with an array from 0 to 3, and you can see here that you have 4 jobs running. And by Slum gives a job ID in the form the job ID of the bot jobs underscore the task ID. So you can see here. And one trick is that you can cancel all the elements of all the tasks for a job array with only one ascancel command. If you use ascancel and the job ID, you kill all the elements of the job array. But you can cancel only one element if you want. For complex pipelines, Slum also supports dependency between jobs. So in some cases, you don't want a job to start before another is finished, or you want a job to start only with as a recovery for a job that crashed, for example. So you can specify in the bash script of a job that a job has a dependency with another one. So job dependency are used to defer the start of the job until the specified dependency are satisfied. So the job can be of several types. After, for example, after all the job, you can run a job after all the specified job have started, or after all the specified job are finished, or after a specified job have failed. For recovery, for example, here only if the specified job are finished correct and successfully. For example, post-processing. At UNamur, we have a user that uses this kind of trick, job dependency and job array, to run a sort like of algorithm, genetic algorithm. So you only launch one job that generates many jobs and job array, then a job that process the output of the job array and resubmit a job and job array, etc. The trick is you can submit a job within a job. So you can have an automatic workflow depending on the result, and in this case, it use for genetic. on very large supercomputer, reliability, the compute nodes essentially, it become the main challenge. On very big cluster, it is expected that the mean time between failure will be on the order of hours instead of days. So a failure will become the norm rather than the exception during the execution of an HPC application. For this reason, there are failure recovery techniques for long-running jobs, such as, for example, checkpointing. Using checkpointing, when a node crash, you will be able to restart your application, your job, sorry, from the latest checkpoint. For example, you are running a job on one node. You make a checkpoint, the node crash, and you can restart the job from another nodes from the checkpoint, and you continue. It's very useful when you have application that run for several weeks. That's the case on that case. Also, scientific workloads are becoming more complex, and there are many applications that call workflow manager that provide a declarative way to specify the high-level logic of an application. So you can automate the execution of software flow. So different applications that run each after other in a declarative way. And these topics are covered with by the following training session. So preparing, submitting, and managing job with Slurm, using checkpointing restart to overcome the time limit of recovery, and using a workflow manager to handle a large amount of jobs. There are several types of bad jobs you can run on HPC cluster. Several jobs run on one core on one compute node. Threaded jobs can only scale off one single node. So it's a job that uses several cores on the same machine. MPI job can take a full advantage of the size of a cluster by running a job on several cores on several machines. But this kind of application can be hard to debug and hard to profile. And this topic are covered by the following training session: introduction to parallel computing with MPI, and parallel programming with OpenAI. On the CÉCI cluster, several logins, several script languages are available. Among others, there are MATLAB available, Python, R, etc. And MATLAB and Python are covered by this training session. There are also other scripting languages available, such as Tcl, Perl, etc. For example, the following Python versions are available on the CÉCI clusters, and you can install your own. You can install your new library by using pip or compiling from source, for example. If you need the library for your job, you can install it using pip or by compiling by yourself the application in your own VM. MATLAB is a commercial application, so it's not available on all the CÉCI cluster. For example, the 2020 B version of MATLAB is available on Hercules, but only for the UNamur user, because we pay for it. It's quite expensive, but we paid for this software at UNamur. You can submit MATLAB jobs on the Hercules cluster. For example, you can find a very simple job script to run MATLAB jobs on Hercules. So you can submit it, your job is running, and as usual, when the job is finished, nothing is displayed. And in the output file, you find the You can also run parallel jobs running MATLAB. For that, you have to a list of functions with benefit. Which benefit for the threading is in fact available on the MathWorks website. And a multiprocessor MATLAB job only consumes one license token. And we have MATLAB has several toolbox, and we have several tokens for the parallel toolbox that allow the user to parallelize the code. For example, here we can run MATLAB job on for CPU, for example. One thing very interesting with MATLAB is the compiler. The MATLAB compiler allows generate standalone executable. So when you compile a code with MATLAB, the executable generated can be run outside the MATLAB environment. Okay, so without using a MATLAB license. So you can compile your application on one cluster that provides MATLAB and run on another cluster. Beware that not all the functionalities can be compiled. You have to check on the MathWorks website which functionality can be compiled. And when you run your application, you have to, before running the executable generated by the MATLAB compiler, you have to load the corresponding MCR. MCR stands for MATLAB compiler runtime. For example, you can compile your very complex code using the MCC command. Then when it's compiled on the same cluster or another cluster, you load the corresponding MATLAB runtime and you run your application like any executable. And that's it. This topic covered by several training sessions on the transition to scripting and interpreting languages, Python, R, and Octave, introduction to Python, and also efficient use of MATLAB on the cluster, and the same for Python, the efficient use of Python. But no, I have my own code, and I want to run my own code on the cluster. On HPC system, in fact, to get maximum performance, you have to recompile your application for each cluster you use. We will take a look at the different tools you can use to compile your code. On each HPC cluster, there are a compiler. To compile an application, you need a compiler. And there is on the CÉCI cluster several compilers available: GCC, the Intel, and the BGI. The BGI is now owned by NVIDIA. The GCC is the default compiler on Linux, and it's the default compiler on HPC clusters, and it's quite easy to use, but it has pretty good performance. But if you want performance, you should use the Intel compiler. Intel compiler, as well as the Intel MPI, offer the best performance for scientific computing performance. So if you want to have the best performance, you should use the Intel compiler. There is also, say, a Portland compiler available. And when doing GPU programming on GPU, you can try this compiler. It's BGI provides OpenHack, which is a standard designed to simplify the parallel programming on CPU and GPU. And in many cases, you don't need to write your own server. on the CÉCI cluster, there are many optimized libraries already available. So, for example, Boost, GCL, etc. So please don't reinvent the wheel. Don't code your own matrix multiplication algorithm. Can you code use pretty core tune libraries? Compiler, parallel libraries, as well as the optimized library are on the CC cluster are organized as is called a compiler to chain. So, for example, a compiler to chain is a compiler, MPA library, BLAST LAPACK library, donc like linear algebra routines, and fast Fourier transform libraries. For example, we can find for the chain based on GCC this one, and to chain based on Intel compiler. For example, the first chain is based on GCC. They contain the compiler, the OpenMPI library for API, the linear algebra routines, and the fast Fourier transform library. The same for the Intel toolchain. You will find the C compiler, C++ compiler, Fortran compiler, the MPI, and that's what Intel called the MATLAB kernel library, MCAL. MCAL implement BLAST, LAPACK, and also provide a fast Fourier transform library. And this topic is covered by several training sessions, introduction to scientific software development and deployment, introduction to compiler compiling, like optimized libraries, introduction to Fortran, C, and object programming with C++. But now, how to find bugs and how to improve performance for your application on the HPC cluster. In order to improve the performance of an application, first you need to find the hotspot of your application. The hotspot is the section in the code when most of the time is spent during the program execution. And to find this hotspot, there are several tools available. For example, on FLS, there is a tool developed by Intel that allows you to find the hotspot of an application. So the way it works is you run the application with the performance analyzer, and then the performance analyzer will collect the data and then show you where you could spend the most of this time. And this topic is covered by training, debugging, profiling, scientific code, and scientific library. To accelerate application, one possibility is to migrate the hotspot of your application to more powerful computer device. And this device is called Accelerator. The migration of this computation is called computation offloading. And the most commonly used accelerator are, in fact, GPU. That's graphic processing unit. In the HPC world, we call that GPU, general purpose graphic processing unit. And many supercomputers use accelerator to increase the performance of the application, or to increase the size of the scientific problem they can compute. For example, here at CÉCI, there are several GPU available on Dragon 2 and Hercules 2 clusters. And please note here the different performance between the two GPU. For example, the A6000 has the best performance here in a single precision floating point. But the Tesla performs 7 times better than this one on double precision floating point. So depending on your application, you have to use the right gap. And the price is not the same. This one is far more expensive than this one. It's 4 times the price. And GPU will also be available on the LIMI supercomputer. And these topics are covered by this following training session: parallel programming on GPU using CUDA, and directive-based parallel programming on GPU. During this session, the other topics are also covered. So, for example, how to use a container on the HPC cluster, how you store your data using text file, binary file, etc. How to use Git, and also an introduction to neural network and open science. So here are the training session that cover these topics. Now, before we finish, let's talk about our hot topic, the climate change. Now, some models predict that information and communication technologies could consume 20% of the electricity on the world by 2030. So, reaching the carbon neutral data center will be critical for fight against the global climate change. The Green 500 list provide the 500 most energy efficient supercomputers in the world. And the first place is this small cluster, and MN3 in Japan. It's operated by a private company. This private company develop application for deep learning and robotics. LIMI, the first European scale supercomputer, is now in production. A few weeks ago. It's one of the most powerful supercomputers in the world, but this supercomputer will run with a negative carbon footprint by using only renewable energy, and the waste heat generated by this supercomputer can be used by 20% of the house surrounding this supercomputer. As a reminder, it's located in Finland. It's quite cold out there, so it's quite interesting. And as energy consumption and associated costs may become a major issue, a free online online tools allow you to compute to estimate the carbon footprint of your calculation. You can try this it, enter the data, and see how many trees you need to run your application. And for me, that's it. Thank you for your attention.